Imagine the surface of Earth becomes too dangerous to live on. Maybe the temperature has dropped too far. Maybe radiation is too high. Maybe agriculture has collapsed. Maybe extreme weather has made normal cities impossible to maintain. Whatever caused it, humanity has one giant question. Where do we go? One answer sounds almost like science fiction. Underground. Not bunkers, not tiny shelters. Entire cities, homes, hospitals, farms, schools, factories, transportation. Everything we normally build above ground would have to move beneath it. So could we actually do it? And if we could, what would an underground city need in order to keep people alive for decades? The first problem is obvious. Air. A city underground cannot simply rely on opening a window. Fresh air has to be brought in continuously. Carbon dioxide has to be removed. Humidity has to be controlled. Dust, smoke, chemicals, and other contaminants have to be filtered. So the first system in an underground city would not be roads. It would be ventilation. Think of the entire city almost like one giant breathing machine. Large ventilation shafts would connect protected parts of the city to the surface. Air would move through filters. Backup fans would keep airflow moving if one system failed. Sensors would constantly measure oxygen, carbon dioxide, smoke, temperature, and humidity. And the most important rule would be redundancy. One air system would not be enough. If a city of thousands depended on one fan, one power line, or one shaft, that would be a terrible design. Every critical life support system would need backups. Then comes water. People can survive without luxury. They cannot survive without safe water. An underground city would need access to groundwater, stored water, pipelines, or some combination of all three. But bringing water in is only half the job. The city would also have to recycle it. Water from sinks and showers could be treated and reused. Wastewater would need advanced treatment. Industrial water would have to be separated from drinking water. And leaks would matter much more underground. A broken pipe above ground is inconvenient. A major uncontrolled leak underground can flood rooms, damage electrical systems, and block evacuation routes. So water infrastructure would be designed with isolation valves everywhere. If one section failed, engineers could shut it off without losing the whole system. Now we have air. We have water. What about food? This is where the city becomes much more interesting. If the surface is no longer reliable for farming, food production has to move underground too. We cannot grow millions of acres of crops beneath a city. There is not enough space, so we have to think differently. Vertical farming becomes extremely important. Plants grow in stacked layers. Artificial lights replace sunlight. Hydroponics or other controlled systems deliver water and nutrients directly to roots. Every square meter has to produce as much food as possible. That means the city would probably prioritize crops that grow quickly and provide good nutrition. Leafy vegetables, potatoes, legumes, certain grains, mushrooms, possibly algae and microbial protein. Food would no longer be designed mainly around variety. It would be designed around calories, nutrition, space, water, and energy. And that gives us another problem. Electricity. An underground city uses power for almost everything. Lights, ventilation, water pumps, food production, hospitals, transportation, heating, cooling, communication. If the electricity fails, life support systems begin failing too. So, how do we power the city? If conditions on the surface allow it, power could still come from nuclear, hydroelectric, geothermal, wind, or other sources. But geothermal energy would be especially attractive. The deeper we go, the warmer the Earth becomes. That does not mean we can simply dig anywhere and get unlimited power. But in the right locations, geothermal systems could provide dependable heat and electricity. Nuclear power would also be valuable because it can generate large amounts of energy without depending on sunlight or weather. And again, redundancy matters. A city should not depend on a single power plant. Several independent systems would be much safer. Now we have another question. How deep should the city be? Too shallow, and it may not provide enough protection. Too deep and construction becomes far more difficult. The deeper you go, the greater the pressure. Rock becomes hotter. Removing excavated material becomes harder. Ventilation becomes more demanding. Transporting people and supplies takes longer, so the smartest design probably would not be one enormous cavern several kilometers underground. It would likely be a network of connected districts at manageable depths. Think of separate neighborhoods linked by tunnels. If one district has a fire, flood, structural failure, or contamination problem, it can be isolated. That is much safer than putting everyone inside one giant underground room. Transportation inside the city would also look different. Cars would probably be inefficient. They create heat. They need large tunnels. They consume space. And combustion engines create dangerous exhaust. So underground cities would likely depend heavily on electric rail systems, automated shuttles, elevators, moving walkways, and bicycles. Most daily destinations would need to be close together. Homes near schools, homes near food distribution, hospitals near transportation hubs, industrial areas separated from residential sections. Everything would be designed around minimizing travel. Then we reach one of the hardest problems: waste. A normal city generates enormous amounts of it. Food waste, human waste, packaging, broken equipment, industrial materials. If you are underground, you cannot simply keep piling waste outside the city forever. You need a closed system. Organic waste could be composted or processed into fertilizer. Some waste could produce biogas. Metals would be recycled aggressively. Plastics would be reused whenever possible. Water would be cleaned and recirculated. A successful underground city would have to waste far less than a modern surface city, because everything that enters the city costs energy to move, and everything that leaves the city costs energy too. Now we get to fire. Fire is one of the biggest dangers underground. Smoke has nowhere to go naturally. A small fire in the wrong tunnel could become deadly. So buildings would need fire-resistant materials. Sections would need automatic doors that can seal smoke away. Ventilation systems would have to reverse or isolate airflow. Every district would need multiple escape routes. Emergency shelters would need their own air supply. And firefighters would need to know exactly how smoke is moving through the tunnel network. Then there is flooding. Groundwater pressure can be powerful. Rainwater from the surface can enter tunnels. Pipes can rupture. Pumps can fail. So every underground district would need drainage systems, sump pumps, waterproof barriers, emergency flood doors, and elevated critical equipment. Hospitals should not be placed at the lowest point. Electrical rooms should not be placed where water naturally collects. The city itself would have to be shaped around water flow. That brings us to something architects do not normally have to think about this much: psychology. Humans evolved under open skies. We expect sunlight, distance, weather, day, and night. Underground, all of those cues disappear. People could become stressed if every room looks the same and every ceiling feels low. So architects would need to create the illusion of openness. Large public spaces, high ceilings, artificial skylights, screens that simulate daylight, green areas, water features, changing light colors that mimic sunrise and sunset. Even the shape of hallways would matter. If every tunnel is identical, people can feel trapped. If different districts have unique colors, plants, art, and architecture, they begin to feel like real neighborhoods. This may sound cosmetic. It is not. Mental health becomes part of life support. If people are going to live underground for years, the city cannot feel like a bunker. It has to feel like home. Now imagine a power failure. What happens? The main grid shuts down. Emergency batteries take over instantly. Critical lights stay on. Ventilation continues. Hospitals switch to emergency power. Water pumps keep running. Then backup generators or another independent power source starts. That sequence has to happen automatically. There cannot be 10 minutes of people wondering what went wrong. The city itself needs to respond before people do. And what if one entire district becomes unsafe? Maybe there is a fire. Maybe toxic gas enters a tunnel. Maybe part of the structure is damaged. That is why the city needs compartmentalization. Heavy doors close. Airflow is isolated. People move through alternate tunnels. Emergency shelters activate. The rest of the city continues functioning. A resilient underground city should fail in pieces, never all at once. Now let us talk about construction. How do we actually build something this large? We would probably not dig one giant hole. Tunnel boring machines could create the main transportation corridors. Existing mines or tunnels might be reused in some locations. Large chambers could be excavated for farms, hospitals, storage, and public spaces. Concrete, steel, and reinforced rock structures would support critical areas, and construction would happen in stages. First, life support infrastructure, then power and water, then basic housing, then food production, then schools, offices, recreation, and everything else. You do not build an underground shopping district before you know where the oxygen comes from. The priorities are very different. And then there is the surface. An underground city would still need access to it. Air intakes, energy infrastructure, communication antennas, emergency exits, food or material deliveries, scientific equipment, so the surface would not be abandoned completely. It would become a controlled support zone. People might only go outside when conditions were safe. Robots could do much of the dangerous work. Maintenance drones could inspect structures. Autonomous vehicles could move supplies. The more dangerous the surface becomes, the more valuable automation becomes. So could we build a city underground today? Yes, parts of it. Humans already build deep subway systems, underground laboratories, mines, bunkers, data centers, storage facilities, tunnels. The engineering principles already exist. The difficult part is scale. Building an underground city for a few hundred people is one thing. Building one for hundreds of thousands is completely different. The energy requirements would be enormous. The cost would be enormous. The excavation would take years, and every major system would need backups. So if humanity ever believed the surface was becoming permanently dangerous, the smartest strategy would not be waiting until the last minute. We would need to start early. Choose locations near reliable energy and water, build transportation tunnels, install power, create food production systems, test ventilation, train residents, then expand gradually. The biggest mistake would be treating an underground city as a giant emergency shelter. It would have to be designed as an entire ecosystem. Air goes in, carbon dioxide comes out, water is cleaned and reused, food grows under artificial light, waste becomes raw material, energy powers everything, people work, children go to school, hospitals operate, trains move, and above all of it, hundreds of meters of rock protect the city from whatever made the surface unsafe. So what would the survival plan be? First, choose the right location. Reliable rock, reliable water, reliable energy. Second, build multiple independent life support systems. Never depend on one ventilation shaft, one power source, or one water supply. Third, grow food inside the city. Fourth, recycle water and materials aggressively. Fifth, divide the city into separate districts so one failure cannot destroy everything. Sixth, design for human psychology, not just survival. And finally, keep a safe connection to the surface. Because surviving underground does not mean giving up on the world above. It means creating somewhere safe enough for humanity to wait, adapt, and eventually return. That may be the strangest thing about underground cities. They sound like a symbol of collapse, but they could also be a symbol of resilience. If the surface becomes hostile, humans do what humans have always done. We change the environment around us. We build shelter. We move resources. We solve one problem, then the next, then the next. And eventually, a place that once looked completely unlivable becomes home. This is Dreamframe TV. Impossible disaster, real science. And one question: what would we do next?